I'm Weaire. I'm from the School of Physics of Trinity.
My name is Phelan. I'm a former research student of Dennis's.
People have asked, what's the ideal structure that's made up of bubbles of equal size? Now, what does ideal mean? Turns out the structure of lowest energy is the one which has the lowest surface area. So you want to pack those bubbles together like this in such a way that they use a minimum amount of surface area. And that's what we call the Kelvin problem. And the Weaire-Phelan structure seems to be the solution to that problem. At that time, the champion structure was the 1887 structure of Lord Kelvin, the great Lord Kelvin.
This particular puzzle was one which had been effectively open for about 100 years. And as Dennis said, there were a whole range of potential sources of inspiration for better answers to this particular question, this particular puzzle that Kelvin had posed. So in terms of how we got to the actual number which proved that our solution was better, what it actually involved was talking to a lot of people. So we talked to people in the States who were experts in modeling complicated structures. We talked to people elsewhere who were experts in crystallology and other areas of physics who could tell us how these things are configured. Putting that together, we then sat down with our rather powerful computers here in Trinity and started to do the calculations, to visualize these particular structures, work out, are these better or worse than the original Kelvin solution. And as Dennis said, on a rather glorious day, I think it was December 1993, we kind of got the number on the screen and realized, you know what, this is actually better than Kelvin. This is probably an important result.
Well, we have here a model of one corner of the water cube in Bejing. It consists internally and structurally of massive steel beams, which are connected in just exactly the same way as the Weaire-Phelan structure. And on the surface, you see that a cut through that structure. The man who conceived this is called Tristram Carfrae, and he decided to respond to the brief of the Chinese by trying to represent water, which was what they wanted, by having a structure that was in some sense made of bubbles.
I actually did manage to meet with some of the project team who built it, and they were just so incredibly proud of the fact that they managed to do this. I think it was very gratifying to see that some of the huge amount of effort that the whole team had put into doing this work had actually realized something so physical and so visual.
The Guardian newspaper, who were the first people who covered this, said that we might have achieved immortality. A wonderful thing about doing basic research and mathematically relevant things is that they do have a hope of lasting as long as civilization. So that's a nice reward in itself. Anyone who's interested in the structure itself and how it fits together would do well to get one of these little kits from the exhibition shop. With that and a little patience and using the instructions provided, you can build these three representative bubbles or cells that are part of the structure.